5 basic mechanisms of transmembrane signaling. 5 basic mechanisms of transmembrane signaling are well understood. Each uses a different strategy to circumvent the barrier posed by the bilayer of plasma membranes. 5 basic mechanisms of transmembrane signaling. 1. The receptor is intracellular receptor. The receptor itself is enzyme or regulator of gene transcription. The drug should be lipid soluble, for example, hormone. 2. The receptor is transmembrane protein. They have extracellular domain and cytoplasmic domain. When drug bind to the receptor, they activating an enzyme of activity in cytoplasmic domain. 3. The receptor is also a transmembrane protein. When drug bind to the receptor bound to a separate protein tyrosine kinase. 4. The receptor itself is ion channel. 5. Is G protein receptor. It linked to a vector by G protein. For example, acetylcholine receptor is ion channel. When acetylcholine binds to the receptor, the ion channel will be open. EGF molecule. Epidermal growth factor EGF receptor. The receptor is a receptor binding to tyrosine kinase. When EGF binds to the receptor, the cytoplasmic domain becomes phosphorated, P, on specific tyrosine residue, Y, and their enzymatic activity are activated, catalyzing phosphorylation of substrate protein, S. For example, insulin receptor is a receptor of tyrosine kinase. When insulin binds to the receptor, tyrosine residue was phosphorylated. Tyrosine kinase become active. They could phosphorylate the substrate protein. Here is glucocorticoid receptor. The receptor is inactive when they bind to hot shot protein 90. The steroid bind to the receptor. The receptor dissociate hot shot protein 90 and become active. They enter into the nucleus and bind to the DNA. They could alter transcription of specific genes. Here is the G protein receptor. The receptor linked to the effector through G protein. 5 basic mechanisms of transmembrane signaling. 1. Receptor they are intracellular. 2. Receptor located on membrane-binding enzyme. 3. Receptor located on membrane-binding molecule that bind separate intracellular tyrosine kinase molecule. 4. Receptor located on membrane's ion channel. 5. Receptor linked to effector via G protein.